Following question is related to chemical bonding, and the question states that which molecule has only 4 electrons involved in covalent bonds. So we need to figure out this thing over here, 4 electrons in a covalent bond. So for that, we need to draw the dot and cross diagram for each element, each molecule that's given. So let's look at the first molecule first, which is an H2S molecule. So I'm going to draw sulfur first. So this here is a sulfur atom, and sulfur is in group 6, which means that it has 6 electrons in its outer shell. So there I have drawn 6 electrons. Now since it has 6 electrons, it needs 2 more electrons. So it's going to share 2 electrons. And it's going to share 2 electrons with each of the hydrogen atoms. So I'm going to draw 2 hydrogen atoms now. So I have drawn 2 hydrogen atoms. Hydrogen just has 1 electron. So if it has 1 electron, it needs 1 electron to complete its outer shell. Remember, the first shell only has space for 2 electrons. So hydrogen is going to share 1 electron. So there would be 1 electron shared by hydrogen. So sulfur is going to share 1 electron with that particular hydrogen atom. The other hydrogen atom would do exactly the same. It only has 1 electron. So it's going to share 1 electron with sulfur, and sulfur is going to do exactly the same. So if you look at this molecule, sulfur was in group 6. It had 6 electrons in its outer shell. So it needed 2 electrons. 1 electron came from hydrogen. The other one also came from another hydrogen atom. And that's how sulfur got its 8 electrons. So there are 2 electrons being shared over here, and there are 2 electrons being shared at the other end as well. So the question was, which molecule has only 4 electrons involved in covalent bonds? So there are 2 electrons in this covalent bond, and there are 2 electrons in this covalent bond. So this fits perfectly with this. There are a total of 4 electrons being shared. So H2S is probably the correct answer for this. It's a correct answer for this question. But to confirm and to revise dot and cross diagrams, I'm going to do all the other rest of the options as well. So let's draw the dot and cross diagram for carbon dioxide. And first I need to draw carbon. Now here's a carbon atom, and carbon is in group 4. So it has 4 electrons. And if it has 4 electrons, it's going to share, it needs 4 electrons to complete its outer shell. So it's going to share 4 electrons. And it's going to share those 4 electrons with 2 of the oxygen atoms. So I'm going to draw the oxygen atoms. So here are my 2 oxygen atoms. This is oxygen. Oxygen, remember, is in group 6, which means that it has 6 electrons in its outer shell. It needs 2, so it's going to share 2 electrons. So 2 electrons are being shared, and it has a total of 6 electrons. So there are 4 electrons left behind. So what carbon and oxygen would do is they're going to share 2 electrons each. So there's a double bond over here, a double covalent bond. The other oxygen is also going to do exactly the same. It has 6 electrons, so it needs 2, so it's going to share 2 electrons. And there would be 4 electrons left behind. So oxygen needed, it had already had 6 electrons, it needed 2 electrons. Those 2 electrons came from carbon. So if you look at the molecule of carbon dioxide, there are 4 electrons being shared in one covalent bond and 4 electrons being shared in the other covalent bond. So that's a total of 8 electrons. Hence, option B is the incorrect option. We're now also going to discuss this chlorine molecule, Cl2. Chlorine is in group 7. So it needs 1 electron. So it's going to share 1 electron. So I'm going to draw the dot and cross diagram for chlorine. So here are my 2 chlorine atoms. Cl is in group 7, so it has 7 electrons in its outer shell. So it needs 1, so it's going to share just 1 electron. The other chlorine atom is also in group 7, so it's going to it has 7 electrons in its outer shell. So that's 6. 7, it needs 1 electron, so it's going to share just 1 electron. So if you look at the molecule of chlorine, the dot and cross diagram, there's a covalent bond, but this covalent bond only has 2 electrons. So there's only a single covalent bond in chlorine. So hence option C is also the incorrect option. Now I'm going to discuss this nitrogen molecule. If you look at this nitrogen molecule N2, nitrogen is in group 5. So it has 5 electrons in its outer shell. So it needs 3 electrons, which means it's going to share 3 electrons. So I'm going to draw a nitrogen molecule now. So here are my 2 nitrogen atoms. Nitrogen, remember, is in group 5, so it has 5 electrons in its outer shell. It needs 3 electrons, so it's going to share 3 electrons, and since it has a total of 5 electrons, 2 would be left behind. And the other nitrogen atom would do the same. It's in group 5, it has 5 electrons in its outer shell. it needs 3 electrons, so it's going to share 3 electrons, and 2 electrons would be left behind. And in this way, each nitrogen atom needed 3 electrons, so it started sharing 3 electrons with the other nitrogen atom. So this is the molecule of N2. And if you look, there are 6 electrons being shared in this triple covalent bond. So this is also an incorrect answer. The only correct answer was option A, which is H2S. 2 electrons over here being shared, 2 over here that are being shared. So that makes a total of 4 electrons. Hence option A is the correct option for this question.